Hello, thank you so much for joining us, whether you're joining us live or later on for the recording. I want to make sure that you know how to submit any questions that you might have during this presentation. If you're on a computer, it's going to be off to the side. There's a little question mark. It says just click that and type in your questions there. If you're on a tablet, it's going to be right above us. And then finally, if you're on a cell phone or a smaller size screen, it's going to be right down at the bottom. Just click on those buttons. You can submit questions. Even if this is a recording, we'll try to get answers for you. Those of you who submitted questions before the presentation, we are going to ask them, so please stay tuned, pay attention. I think this is going to be a really great session. We're very excited. So thank you so much, Rose, for joining us today. And at this point, I'm going to pass it off to you for your wonderful presentation.
All right, awesome. Well, good morning. Thank you again for joining us today as I do a quick introduction into data analytics and the life of a few different professions within the data analytics world. Again, my name is Rose Legis. I am the CEO of RL Engineering and Tech Solutions. A little bit more about me. Not only am I run my own engineering and tech solutions consulting firm, I am also the executive director of Black Orlando Tech. Black Orlando Tech is a tech nonprofit here in Orlando, Florida. We focus on getting more individuals from underrepresented and underestimated communities into tech, either through careers or professions. We have a couple of programs, one where we teach individuals tech skills, regardless of their background. So you could have zero tech experience, you could be of any age, though we do focus on, junior and seniors and up to adulthood. And you could also have no degree, and we will teach you a tech skill that you're interested in and help you get certified, provide you with opportunities to gain work experience, and then also leverage our connections to get you a position within one of these large tech and engineering companies here, or even get you a remote position where you can work from home and obviously, get you into a position where you're making a little bit, possibly more than likely a lot of money, and also get you into the tech world. And then we also have programs where we help those who are building tech startups and tech companies, and help them with their their model, with finding funding, getting their business set up, and just being successful and profitable. I have a bachelor's degree in industrial engineering, which I obtained from University of Central Florida. I worked, my professional certifications, I have a certified in business intelligence, which is actually part of the data analytics realm. I'll go into that in a little bit. I have a certification in advanced data analytics, and I'm also a white belt, Six Sigma white belt, which has a lot to do with process improvement, project management. It's in that realm. I worked out at Kennedy Space Center for about 14 years. I had an internship right before in college, right before I graduated college. That turned into a full-time position, and I worked out there for 14 years in various engineering and also data analytics positions out there until I left in 2019, when I left to start my own business. And I've been running my business, my consulting firm, for the last 4 years. Currently, I'm a big proponent of always learning, especially when it comes to tech. There's always this new technology that's out there. So I'm always learning new things. And so currently I'm learning new skills. One is Python. I would consider myself in the intermediate, which is middle. The way I look at it is beginner, intermediate, and advanced. And I consider myself intermediate with Python. And so still continuing to learn that and hone in on my skill. I'm also learning AI. I consider myself beginner, a little bit between beginner and intermediate with AI, artificial intelligence. And then I'm also doing deep learning, learning more about deep learning. My goal is to get myself to expert level with all three of those. And then once I, conquer those, then I'll be on to the next tech skill, emerging tech skill that's out there. And then just a little, insight into my hobbies. I love watching K-dramas. And so if you know about K-dramas, they're Korean dramas. I love watching them. I actually like watching a lot of international shows. I actually don't watch, and that's if I watch TV, but I don't really don't watch any American shows. There's a few American shows that have over the last 8 years that maybe I've watched, but I'm really big into just international Korean dramas. I like Indian, like Bollywood, and then also African dramas too. I love traveling. I just got back from Lisbon, Portugal. I was there for about 5 days, went there to a tech conference, but also to just visit that location and country, and it was just beautiful, amazing experience, especially when you step out of your what you've always known here in America and just see how other people are living, and also seeing how tech is in countries in places outside of the US. One of the things I identified is there's a lot of tech for good and things happening out there, so just very interesting. I like rebuilding computers. I have 5 laptops here right now that I'm rebuilding. I just love rebuilding them, and then when I'm done, I do like to donate them to those who are in need. And then I love hackathons. I like attending them, and I'm starting to get into, I've actually thrown a couple of hackathons through Black Orlando Tech, and I'm looking to do more and more of that and have more hackathons here in Central Florida in the Orlando area. So let's get into what is data analytics. So data analytics is basically the process of inspecting, cleaning, transforming, and modeling data to gain insights from the data in order to derive conclusions for better decision making. So it's basically taking data, you clean it, you transform it into what you need it, how the structure that you need it to be, you analyze it, and then you obtain from that data the insight that you're looking for. Whatever it is, the objective that you want from that data, you gain it, and then you utilize those results to make some decisions, whether within your business, either within whatever your goal was. And so that's essentially what data is. Why do we do this? In terms of data analytics. As large amounts of data is generated, the need to extract useful insights is a must for business, and is a must really across the board for a lot of things, because data is facts. There are things that you cannot argue. You can't argue, facts. You can't argue factual information. It tells you and it gives you a deeper insight to what is happening. And that could be in any area. It could be what is happening in your business. It could be what is happening in your social media presence and your platform. What is happening in your own personal finance. I mean, data can be, and those insights can be utilized in any situation, from, your work to your personal business, your own business, and to your personal life. Data analytics plays a key role in improving businesses and improving projects, improving your life, improving your finances. It really works on improving and making things more efficient and just streamlining a lot of different projects and things. It allows for uncovering hidden clues or insights that could be analyzed against requirements, against goals, against strategy. And reports generated that are generated from the analysis can be used for strategic decision making in business. And so data analytics is very huge in business and is critical in business, on again, both from the perspective of working for a business and also running your own business. Data analysts translate numbers into plain English. They are literally translators. They're taking this data they're taking the analytics and the numbers and the insights that come from them, and then they're taking that and translating it into a way that the stakeholders are those who uh, have something important, like they have an important need for the data and the project, and so you're translating that information to that audience, whoever that may be, and that's what data analysts do. And then they deliver the value to the company by collecting data on specific topics, and then interpreting and analyzing and presenting findings in comprehensive reports. I wanted to give information on just basic salary and perks in being a data analyst. And so as you see, on average, data analysts can expect a salary of around $84,000 a year. And below are data analyst salaries compared by major companies. And so at the low end, you see JP Morgan and Chase, that's Chase Bank. They pay their analysts, which another thing about data analytics is it can happen in different industries. So it's not just happening in one area. You can be a data analyst in finance, in sports, in healthcare, in literally anything, because data is everywhere across the board. So they pay their financial analysts around $66,000 a year. So that's the lower end. And then you go to the higher end with Netflix. And obviously that makes a lot of sense because Netflix is literally, their business is data. And so Netflix pays their analysts $180,000 a year. And so you can see the range of some of these big companies here and how much they pay their analysts. And then the possible perks of being a data analyst is you could work remotely. Before I started up my company, I worked remotely. I could do all my stuff on my computer. I didn't need to be in the office, and I love that because it saved me a lot of stress. I wasn't driving to work. I could set my schedule as long as I completed my assignments and had the reports going. If there was need for me to be at a meeting, then I could be, obviously, especially during the last 2 or 3 years, we've been virtual because of the pandemic, but that's still happening and people can still get jobs virtually. And then usually, depending on the company, you might get a sign-on bonus when you get hired between $1,000 to $10,000, which is like a one-time lump fee, if you not fee, but payment to you, and they're hiring you because of your skill set in order to obviously attract you to that job and get you there. And then this information, the U.S. Bureau of Labor Statistics indicated that data analytics are projected to see a faster than average growth of 19% between 2014 and 2024. So it's always climbing, it's always growing, and there's always positions out there for data analysts. All right, so what are the 4 main facets in the analytics space? The 4 main facets, which is the 4 main parts of data analytics, is business analytics, business intelligence, data analytics, and then data science. So business analytics is basically a field that drives practical and data-driven changes in a business. Refers to the skills and technologies for continuous exploration and investigation of past business performance to gain insight to drive business planning. So literally you are looking at the data of the business, the data that's already happened, and this is most of that data is what I call data that's already passed, this past business performance. And so that means the sales that have already happened, the revenue that's already happened, how much, all this data has already happened in the past, but you can analyze that data, find trends to be able to forecast. So an example is, if I go and look at my sales history over the last 3 years, I can then use that data to identify what audience do I sell to the most, when do they typically buy more of my product, meaning I see that for over the last 3 years, there's always the largest time that my product sells is around Christmas time. So what does that do for a business? It lets me know that, number one, around Christmas time, I need to make sure I have enough product because I don't want to run out. And so you would not carry the same amount of product during, in throughout the other parts of the year than you would at during the time frame that you sell more. You would actually most likely have, again, based on the data, probably double the amount that you typically have because you know that you're going to sell a lot more, and you make that determination based off the data and the history that it shows. It also tells you who is your highest, what's your demographic when it comes to selling your products. Is it more young people buying your products? Is it more women buying your products? And then that helps you with marketing and seeing who to target when you're doing sales and when you're promoting your items. It makes no sense to go promote an item that a lot of women are buying, and for you to spend money to promote it to men. You would spend more money to promote it to women because that is your demographic that's buying more of your product. Again, this is not stuff that you would only utilize, okay, when you get older, when you get a job. You could utilize that now. If you guys are running your own business, if you guys are influencers, if you guys are on social media, there's things like you can use data analytics to help with things that you're currently doing in high school right now, if those are the type of things that you're looking for. It's the same thing with your social media presence. Who do you market to? Where, what groups do you join that are going to be more in line with what your presence, especially if you're trying to grow your numbers. Business intelligence. Business intelligence provides historical, current, and predictive views on business operations. It comprises in the strategies and technologies used by enterprises for data analysis of business information. Business intelligence is just how it sounds. It's the intelligence within the business and the data of that business, and you're finding the insights, and then you're taking those insights to make changes and improvements within the business. It's that constant improvement of your business based on the information that you're collecting and that you're having, and that constant, improving and making things more efficient. Data analytics obviously is what we talked about before. That is the essence of all of these facets. That data analytics is within all of those. And then data science takes it for me it's taking this a step further, and this is where you start adding in scientific methods, like statistics, modeling, forecasting, algorithms, processes to analyze the data and to extract knowledge from data that's structured and unstructured. And so data science is literally what it means. It's like the data analytics on steroids. It's a lot more science in there, a lot more formulas. This is where you'll start seeing a lot more Python being used because you're doing high level, serious level analytics versus, I want to find the mean or the medium, or I'm looking for a lot more detailed information. I'm looking for forecasting, predicting trends, and that's where data science comes into play. Again, here's the relationships for the four facets within the analytical space. Again, like I stated, data science is up there. It's top dog. It's really deep. And it's a lot more than the data analytics, but it pays a lot, and there's not it's a very just high level profession, and it's really it's not a lot of people in there, but it's really in high demand. Then data analytics, and then underneath data analytics is the business analytics and the business intelligence. All right, so I'm not going to delve too much in this because I think it's kind of down, it's like deep down in there. I just wanted to show you the difference between data analytics and data reporting. And so there's a huge difference in between analytics and just pushing out reports. Obviously, in that analytics, it's a process of a person tackling a problem. So you're finding the data that's required to get the answer. You're analyzing the data. You're interpreting the results in order to provide a recommendation for action. So it's not just, hey, I'll print out this report and give it to someone. Like, you're doing all of this. The reporting is what I'm saying. It's like you set up a standard report to say, print out a report of all my sales for the last month, and that report is repetitive, and it requires you to do nothing beyond to say, I want all sales in the last month, and then you just report it. You produce the report and you turn it in. There's no analytics done. There's nothing else done beyond that. And so as you're looking for positions in there, know that, if a position wants somebody to just produce reports, that is completely, different than somebody who is actually analyzing the data. And before they're before they're giving anything, they're analyzing, finding insight, and then giving a recommendation. All right. Business objectives and goals. And so data analytics aims to solving a business problem or accomplishing a desired business outcome. And so defining those objectives is the vital first step in any data analysis process, because they become the goals of the data analytical model that you create. It's essentially, this is the goal, this is the objective of what I'm about to do. So you need to define that first before you start anything. It drives what sources you get from what you get your data from. What type of data that you're going to collect, how to clean your data, how to design your model and analyze, and finally how to present your findings. And so popular business objectives, customer-centric outcomes. And so these are things where your outcome is based on the customer. I want to increase my sales. That's all going to be based on your customer. I want to I want to improve the shipping of a product in terms of like the shipping time frame, so that way it increases my customers being happy because they're getting their product quickly. So the next one is operational optimization. Again, improving how long a product takes to be made. If you are ordering made to order products, meaning when they place an order, you make it as soon as the order is placed, how in improving that process from 10 days to 7 days, like how to do that. So that's some outcomes or objectives that you may have. Risk management, how to lower the risk in this process or in this procedure. Financial management, again, increasing your revenue, lowering your debt and expenses. New business model. If you have a business and you're looking to create a new model of that business to create additional revenue streams, you would collect data and do some data analytics to see if it's a profitable business model, or how to set it up, so that it is profitable and it is a success. And then HR analytics. It could be employee retention. It could be vacation use, like the different stuff that you would analyze from the perspective of HR. All right, so here's some different business objectives and goals. One, like within a healthcare hospital setting, identifying peak ER waiting room days and times. And so how would that help? If you know that you're busiest on a Saturday night, then what would you do? You would have more people working during that time, because you want to ensure that you have enough staff to serve your clientele at your busiest. And so those are the type of insights that you would do and identify. And then also you want to make sure that you're processing these individuals faster. And so those are the type of information you would get. Cluster patients according to age, medical history, sex, and race. And this might be identifying maybe if a whole bunch of people Identifying insights that are possibly related to age or sex or anything for certain diseases, certain you know, medical situations happening or medical emergencies, just finding information that helps you better the hospital experience, and also identify any potential hazards that are happening. It's like this type of information would have been like oh, I forgot the city with the bad drinking, the pipes where the pipes were and the drinking water was horrible, and it's on the tip of my tongue, so I apologize. But that type of information would have helped. If they were gathering that, they would have seen, okay, why is there an influx of people coming in with this type of medical issue, and they all seem to be coming from the same area, and they're all the symptoms are the same, and then you can identify, okay, there might be an issue happening that's related to the drinking water, which obviously there is. Real estate, identifying areas with an increase in land purchases, correlating increase in home values to new Whole Food locations. That's a big one because Whole Foods, there's certain stores that you find in certain areas, and there's a thing called the Whole Foods effect. Anytime you put a Whole Foods in an area, the home prices increase. Why? Because you typically find Whole Foods in wealthy areas. They also have one for Chick-fil-A. There's a Chick-fil-A effect on home prices. You typically find Chick-fil-A in wealthy areas, and so they were able to identify that because they did these studies to show once a Whole Food was put in this area, the home prices went up. And so there's a correlation between the two. And then the business owners identify what products to recommend to your customers, and then identify customers who are most likely to respond. So there's so much more, but these are the ones that I identified just to give you guys an example of that. So the data analytics process, the typical process when to do a data analytics is, and I'm going to go high level with this, just so we can keep in time because I have some videos I like to show you guys. Define the objective. We went over the different types of objectives that you can define, but the first thing is to define the objective. So you would assess the situation, define questions, and then make sure that the objective is measurable, clear, and concise. Don't define objectives that you are not going to be able to answer. It needs to be reachable and attainable. Next, once you define your objective, produce a project plan. The project plan is going to define what you're going to measure, decide how you're going to measure it, identify the data sources. And so if I'm looking for, home prices, I know that I need to look in Zillow or the directory, the database that has sales of homes, the county property records, those stuff. So those are how you identify where you're pulling this data from. And then select how you're going to model it. What type of modeling technique are you going to do? Then you're going to explore the data. You're going to look into the data, collect it, verify the data is good, take out any data that is bad, clean it, and then prep the data and format the data so that way it can be analyzable. And then you're going to, once you get the data prepped and ready, you're going to analyze it and model it. So you perform the analytics, you perform the modeling technique, and then you test your design. You always test your design to make sure that it's your design is operating properly in the way it should. And so you would test your design, and if you find that your design after you test it is error, then you would go back and make sure, redesign it, improve it, fix whatever is wrong, and then repeat the steps. And then once you're done analyzing, you do your data evaluation interpretation. You evaluate the data, and then you review scope of error. And so if you have data and 1%, there's 1% of errors in there, then you're pretty good. Now, if there's 50% of errors, then there's a problem. And then the deployment. Once you've kind of gone through your data, evaluated the results, identified your insights, you're going to prepare your final reports for your stakeholders, plan do some planning for monitoring and maintenance, because once you set up this analytics, you want to be able to repeat it. And so there's some maintenance and monitoring that's done on there, and then determine the next steps, because you have your insight. Now you need to go and figure out, what are the next steps? Do I give actions? Do I implement? What are the next steps for my stakeholders? All right, this is just examples of some dashboards. So you've done all the data analytics process. Here are some ways, when you talk about the next steps, how you could present the data. You could present it in reports, or you could present it this way, which is on dashboards. Dashboards is front end. It's the front end part of the data analytics, where I'm showing the data on graphs and different visualizations to my stakeholders. And so here are some dashboards for you to look at. This is from Power BI, which is a Microsoft tool. This is a tool that I use heavily especially when I worked in government. And so just is to show you the different type of data on here. So it says campaign revenue versus target, average store, visits by department. This is the type of visualization that you would show and you would gain from your data analytics. Here's another one. This one is a COVID-19. I'm sure you guys remember seeing a lot of these, especially during when COVID first hit. There were a lot of these. So this one is actually from, is this Orange County? This is Florida. Yes, no, I'm sorry. This is Orange County. And so this was the Florida dashboard. I selected Orange County, and then it will show you this information. Total the number of cases, positive case, Florida residents, positive. So out of those 1,977 total COVID cases, 110 of them were non-Florida residents. How many deaths, how many you're monitoring, the age distribution. So out of those, this number, here are the number per age group, and they were going by, what is this, about 9 years, 9-year spans here. And so this is how you would analyze the data, and no, this is how you would present the data after analyzing it. And then here's one on social media. This is somebody's, I believe this is their analytics. So I know this said digital analytics. Digital analytics is just analytics, but your data source is all digital products, which is, like this, like Facebook, Instagram. It's all coming from digital platforms. And so that's what digital analytics is. It's just like a subset of data analytics. And so here it says social media followers, and this is an influencer's dashboard. They're showing their followers, they're showing their video stats, how many people play their videos. They're looking at their Alexa page views per user, Salesforce account. So this is something that they're looking in. Here's their the money that they're making, the leads, and Facebook demographics. And so this tells them right here, Facebook demographics, it tells me that their highest demographics is 18 to 24-year-old females. Because you can see here, the males are the lighter color, the middle color is females, and then the other color is unspecified. And then here is the age range here. And so the highest number is coming from 18 to 24-year-old females. The next number is 25 to 34-year-old females, and then 25 to 34-year-old males. That's the type of insights that you would gain. All right, so here is the data, different professions within data analytics. I'm going to show you 3 videos of 3 different professions. Try to keep them, short. I just want you to show you the day in the life of these different folks in data analytics, and how it's not data analytics is not. It's not the same person. How do I say this? There is diversity within the field, which is, again, something else that I love. Anybody can do it. So.
Hey guys, and welcome back to my channel. For those of you who are new here, I can tell you guys, I got about 5 points that I want to touch on So like I said, there's a lot of jobs opening up to become a data analyst. So I've been a data analyst full time for about 4 years now. Previously, I was a research assistant for like 3 years, working under a director who did like data analysis and stuff like that. So I learned a lot from working under research folks when I was first getting into my career. So the first thing you really need to do is decide the type of analytics that you want to do. So different analysts have different requirements. So you need to really decide which kind of analyst you want to be. There are research analysts, financial analysts, business analysts, analysts who work in healthcare coding and stuff like that. So you first need to decide what kind of analyst field that you actually want to work in. So when I was an undergraduate, I fell in love with programming. So I know I want to do something with data analytics where I have to program. So you need to find your niche. And once you find your niche, you just need to develop the skill sets that you need in order to become good at it. So in my case, learning SQL or SQL, structured programming, was a big deal for me. In order for me to keep moving forward or stepping forward in my career, I had to learn SQL. And I do encourage everybody to learn SQL at least as like for a basic programming language, have a knowledge of SQL, because a lot of people use SQL. So I enjoy learning SQL, and I decided to develop my skill set in SQL. The second thing that I want you guys to know is, even though you don't have like the specific skill an employer may be looking for, it's okay. Because when I started my job where I'm at now, we use SAS. So I didn't know anything about SAS, but I knew SQL. So you could use SQL inside of SAS interchangeably. So you could write SAS and then still use SQL with proxicals and stuff inside of it. So I have a basic idea of SQL. So even if I didn't know SAS, I could use SQL inside of SAS. Oh, you guys understand what I'm saying? So yeah, so even if you don't know, like, you're gonna learn, because ain't no way you're gonna go on a job and be like, know everything at once, because each employer have their way of doing things. So when I went there, I had to develop their way of doing things and understand how they did things, where they store their data, how they manipulate their data, how they put the data, all those kind of codes and stuff like that. So don't be worried that you don't know like a whole lot of programming or whatever. As long as you have a basic idea and you know, like, you are developing your skill set, it's okay. I also use my SQL. I also did a lot of training in my undergrad years using my SQL, and I really like doing database development and stuff in my SQL. So my SQL and SQL skills were transferable into my career where I'm at now. So the third tip I want to share with you guys is to develop your visualization skills, meaning practice using Tableau, Power BI, SAS, VA, Fire, etc. like that. Practice doing visualizations like in those softwares. I think Power BI is free to download. Tableau, you have to have a license, but there are Excel. Well, I also
I'm going to stop it here. I just want to make sure we have time for the other videos. But again, this presentation, we can send the links in, so you can obviously she has an 11-minute video in case you want to look, watch her whole entire video. We can definitely put that or provide that information to you.
people don't.
So the next one is the day in the life of a data scientist. This one's a cartoon, if you will.
A data scientist is a person who uses data to solve problems, uncover patterns, and gain insight. They often work in businesses and organizations which gather and curate large data sets. A data scientist may leverage knowledge from statistics, computer programming, databases, machine learning, and mathematical modeling to achieve their goals. A day in the life of a data scientist. First, the data scientist needs to understand the business or organizational issues. Then they look for data. They may need to set up an experiment to acquire the data, or the data may already exist somewhere in. If an experiment is required, it is important to write down the hypothesis before proceeding. Once the data is gathered, it is checked and cleaned. Then the right tools for modeling are chosen. For example, R, Python, or another software package. The data and results are then analyzed using visualization tools. The data scientist is looking for important insights and trends and checking their hypothesis. Statistical tests are used to check the results are robust and valid. The learnings, results, and insights are communicated to the stakeholders, usually with the recommendations. For example, a data scientist working for a transport company might identify particular routes that are inefficient and recommend solutions to them more efficient. With the advent of the data age, we can all now, with the help of data scientists, give better insights and make better data-driven decisions.
Okay, we'll move on to the next video.
I'm Ehi Benite, and I'm a data engineer at Liaison Technologies. I've been at Liaison Technologies for about 14 years, and as a data engineer, I'm responsible for designing and building the data structures that I use to hold customer information. Big data is really how we call it right now. I work with the data scientists as well as the data analysts. So we're kind of in the middle. The data scientists define the theoretical components of the system, how all the data points that need to be captured, all the information that's needed, and then we're responsible for designing the objects and building those objects to house that data. The analysts now use the structures that we've built to define their reports, to do the analysis, and dig deeper into that information. So it's a little bit of investigative work as well as architectural work, but data science is a team sport. A lot of people just look at it and envision a DBA behind the scenes or a data scientist behind the scenes, but there are different aspects of it now that big data is becoming more prominent. The journey to become a data engineer has been quite interesting for me. Initially, I started off as an accounting major, and I had an internship at the Auditor General's office, and this was, I'm not going to date myself, but back then, a lot of the push was, get into management information systems, and you really understand how data and information systems affect businesses. So you get best of both worlds. You're not just doing, looking at the history of transactions, you're actually creating systems that can house the data and allow the business to make better decisions and improve their processes. Liaison has been doing master data management for probably about 20 years. People were not comfortable with housing their data in the cloud. It wasn't even called the cloud back then. I think Liaison really had a lot of foresight in creating a platform that allowed for that. But now you see Amazon, iTunes, most industries have moved on to the cloud. It's a completely different set of challenges, and there's a lot of acceptance there. So I think from my side, that's one of the biggest things that I've seen. I'm a computer nerd now. After work, I'm still doing fun computer stuff. But I think for fun, the thing I like the most watching movies, what really gets me excited is how in the movies, how they always demonstrate technology. If you think about the Iron Man movies and how Tony Stark is playing with screens in the air, I've always wanted to see that happen. So that's something that really excites me. I think if you can display data in a way that's engaging, exciting, more interesting, I think you will get a lot more leverage from the reports and the structures that we're building.
All right, so again, we'll provide those videos. The typical skills, tech and business skills needed that the companies are looking for data analysts are base design of data, data wrangling, data mining, analytical techniques and statistical methods, the business intelligence platform and data warehousing, data visualization and reporting methods. A lot of this stuff can be learned, in all honesty, from different courses. I know Black Orlando Tech, I teach the data analytics and I teach these skills, and it's something that you don't necessarily need a college degree on. You can get certified, and that certification process that you go through to get the certification and learn these skills is enough for a lot of employers. That's usually what they're looking for, and then experience if you can add on some experience. But those are the different types of skills that you really can obtain even from on YouTube. There's a lot of different free programs through YouTube, through Coursera, through edX, and different Microsoft has their own certification and courses that you can go through. But there's a lot of opportunity that you can learn this now. You don't have to wait until you graduate high school. You don't have to wait until you get to college. You can learn this now and literally get a data analytics internship based off teaching yourself, or joining an organization that teaches it to you, where you can learn in a group. And then business skills, you just need effective communication skills, because you are translating and communicating this data, creative thinking, thinking outside the box when it comes to the data and insights that you're trying to gather, industry knowledge. And so if you're identifying, what industry that you're working on, just having knowledge of the financial industry, the healthcare industry, whatever it is that you're focusing on when it comes to the data analytics, and just problem solving, which that's one of the things I've always known that I'd love to do. And so that's why I fit into data analytics. I feel like I fit into data analytics so well, because I love to problem solve. I've just always been that solution development person. Okay, so this is the end of my presentation. Now open up for questions.
Awesome. We just have a couple, well, actually about 5 questions.
Mhm.
The first one was, how do you use data to make decisions about your own company?
So I use data in multiple ways. My company, I provide services to primarily government agencies, so government contractors, and large corporations. And so I use data. I actually create data analytic solutions for them. And then for my business, I analyze, number one, I have revenue goals. I have how much money I would like to bring into my company. And so in order to make sure I stay on track, I break down all of my goals into bite-sized pieces. And so if my goals are based on some numerical value, like the number of clients I would like to have, the number of contracts, the number of how much money I want to bring in, I break that down from a year down to what I consider bite-sized pieces, which is as low as monthly. Here's my monthly goal. And so if my goal is to bring in $500,000, I break that down into how much do I need to bring in a month, per month, how much do I need to bring in per quarter, which is every every 3 months, and then how much I need to, what are my milestones. So by halfway through the year, I should be at $250,000, and if not, what do I need to do to make sure I reach my goal? Now, obviously, you would think, okay, I would make the same amount of money every month, and that's not how it goes. You're going to have months that are low months. So I know what my low months are, because the amount of money I bring is dependent on my clients, and I know what cycle they go on. And so they have their own, like the government has a calendar year that's not, or has their own fiscal year. That's what they call it. It actually goes from October 1st to September 29th. So October 1st of the one year, all the way to December 29th or September 30th of the next year. That is their fiscal year. That does not align with my calendar year. And so I know I take their year, I put it on my year, I'm able to identify how their months and time period correlate with mine. I know when my low months are, because my low months, right when they're ending their year, they're trying to spend a lot of the money that they have. I know that's going to be my busy time frame. So my busy time frame most times is between July and October. Why? Because they're like, we need to spend this money before the end of the year, because they have a budget. They have to spend what they get, or they don't get as much the next year. So I know that's my busy time frame, and more than likely I'm going to bring in more money. And so I also use that information to say I'm going to need more help, and so I hire more contractors to assist. And so that's kind of how the different ways that I use it within my my business. And I'm a service-based business. I don't necessarily have products. And so when it comes to shipping and delivering, those things don't apply to me, at least not right now. Next question.
How do you handle anomalies or weird data that shows up?
I do root cause analysis. That is something else I learned from my engineering background. Depending on the amount of anomalies that I have and how big of an impact it is, I will do a root cause analysis to basically work backwards to find where did it come from, its source, and what may have made it an anomaly. It may have been that because of something I did incorrectly within my analysis. So that'll be the first thing that I look into is this an error on my part? If it's not an error on my part and the data is true, what impacted it? What skewed, not screwed, but skewed, which is SKEU, skewed this data? And it could be some other factors where it looks like an anomaly, but there was a bleep, if you will, during that time frame. Maybe just like the pandemic, with folks who had businesses that had where they bought their items from China, and the pandemic happened and they shut down shipping, and people were left where they, their data is showing consistent filling of orders, and all of a sudden you have 3 months where their stuff is backlogged, they can't fill any orders. Now, if you're looking at 3-4 years of data of data, that looks like an anomaly. But then when you do the root cause analysis, you identify this was at the start of pandemic. This is when they stopped shipping, allowing any products from, especially from the, China and those countries. And that is why the data is skewed and why I have these what look like errors, but they're actually real data. Is just that this is it. And then once I identify that, then I'm able to identify what I need to do with that data. Do I keep it in there? Do I take it out? That's how I do it. So I always do a root cause analysis, identify what the cause is, and then I choose if I want to remove that data so it doesn't mess up my data, or do I keep it in there with the understanding of this is why this data, this part of the data looks like that. Okay.
What are some ways to know if you would like a career in data?
Well, the way I feel like the way you'll know is actually working in it and doing some projects in it. You can collect data anywhere. I mean, Google is at your fingertips. So if you're trying to collect some data to pull, just find out which one that you want to play with. You can actually look into GitHub has data repositories that you can pull data from. You can get data from your social media. So if you have your different social media accounts, you can go into the analytics part and pull data. So pull a data set and then do some analysis on it. You can have it, some of those data there that you pull from social media, sometimes they're already structured, already cleaned, and all you would need to do is run them through a program. And you could do that to where you run it through a program and it will do the analysis for you, or it will show you how to do it, and see what does that make you what does that do for you? Do you enjoy it? Also encourage you to join different projects. We have hackathons where we do give opportunities for people to work on projects that they would normally not be able to. And so you can join a hackathon, a data hackathon, where you could work on projects. There's a lot of Data for Good, where it allows you to join and help and also learn. And so you're learning at the same time. You are learning from experts, you're doing it for a good cause, and then it gives you that hands-on experience to say, you know what, I like this, or you know what, this is not for me. So my thing is, don't knock it till you try it. Find opportunities out there, which there are a lot of, where you can go and work on a project, do it yourself, and then see if you like it. And you can definitely reach out to me if you're looking for anything like that. It also looks great on your resume, because now that, those hackathons, you can write down on your resume as experience because you worked on it, you gain these skills. Next.
Awesome. And then the final question was, what do you like and dislike about working in tech?
What I love about working in tech is the independency I have, the control of my own way that I want to work and what I want to do. Data is flexible. If I go and do something in finance, I don't like it, I could still do data. I'll just choose to do it in something else. This is why I wanted to show the different types. You can do data in sports. Sport analysts exist. And so if you like, you can literally take, and this is, I feel like it's for a lot of tech, but for data, you could take that and apply it. So you can take tech And this skill set, and this is what I call becoming a unicorn, because I consider and I call myself a tech unicorn. You could take a skill set, the tech side that you love, that's going to give you an opportunity to make a lot of money, get into this world that's, you know, always moving and growing, and then apply it to something that you love. You love sports, you love football, become a football analyst. You love cooking, there is analyst in cooking and that, you know, part of it. If you love to travel, there's analytics in traveling and information within there. You can literally create your own job. And so that's what I like. And I can change it up. I can do one thing one time, and because it's always changing, it's literally always something new for me. I never get tired of it. And so that's what I like. What I don't like is, and so it's something I continue to work on, is the biasness in data, the biasness in tech. And it comes from different ways. And this bias is not just in color of your, you know, the race or gender or sexual, or, I mean, there's so many more. There's the biasness of even language, the biasness of religion, the biasness of even positions, you know. I think that to truly get data and outcomes that really benefit all, the teams need to look like a good balance. And also it needs to make sense. If you are on a clinical trial or project that you're, you know, trying to create a drug to help with cramps from periods, then your team should have women on there. Not to say that your team shouldn't have men. That's not what I'm saying. I'm saying that your team better have women on there, because that is who it's helping. And so does it make sense to have a team of all men who are creating a solution for something that affects women? And so those are, to me, are the type of logical things that make sense that we need to ensure when it in tech, and especially in data. And so that is my mission. I consider myself a data activist, and then also data for good. You know, I just want to make sure that, you know, not only are we utilizing things for fun stuff, but we're also utilizing these skill sets and this ability to create solutions for things to help other people, even if it's not us. And so if I can work on a project where it helps someone in another country, and in regards to something that they're experiencing, then we should be able to do that. I consider that a superpower that I want to yield and I want to be able to utilize. So, you know, we're helping each other in any way we can. And so those are, you know, good and bad of data and in tech is, you know, diversity is definitely key. We need more women. We need more people of color. We need more, able-bodied, not able-bodied. We need more diversity of thought. And we need people in different positions. You know, it's not just execs and managers, because the true superheroes are those who are, you know, sometimes in those lower levels, if you will. But those are the true people who really are working at this, and we need respectability across the board for all of them. So.
Awesome. That was the last of our questions. Is there any remaining thoughts or things you would like to share with students before we wrap up?
No, super excited to have this. I apologize this went over so long. I hope you guys enjoy this and get a lot.
Awesome. There was so much good information there. I know they'll soak it up. I enjoyed it. It was a fantastic session. And please let us know what you thought. For anybody who's watching this recording, we'd love to hear about it. If you like this topic, definitely let us know. We'll try to start, you know, trying to do more of these tech topics. They're so important right now. And Rose, thank you so much. There was so much great information in that.
Yeah, and feel free to reach out to me on LinkedIn. You can find me, reach out to me. I would welcome your questions, anything, any support I can give, I would definitely do what I can. So reach out to me.
Awesome. If you need any of that connection information, just reach out to stemCONNECT. We can connect you right away if that's easier. But thank you so much, everyone, for joining and watching. I hope everyone has a wonderful rest of your day. And thank you so much for joining.
Thank you. Bye-bye.